Good morning, everyone. Welcome to the yet another sessions on data. Primarily in this series of sessions, what we are doing is we are going to each of the different types of different components or different pillars of the different data architecture and data frameworks. And as you have seen in the previous sessions, we have covered different topics like data management, data ethics, governance, architecture, data modeling, data storage security. All of this is part of the entire playlist, right? Now, today, what we're going to do is we'll continue with our journey again with a very interesting and very important component of the overall data frameworks, and which is part of essentially any most of your use cases. So today we're going to look into data movement and different ways of data movement from store one source to your target, from one storage, one database, one application to your target, as part of your data integration and interoperability. Now, DII in other terms, data integration and operability, we're gonna look into the different components, the different goals and principle, core essential components and concepts around it. And then we'll also look into the different methods, how do you basically, what are the different types of activities which are part, what are different types of technologies that are involved during your data integration. We'll also see some of the rules engines, the techniques around it. Okay. So very interesting, again, very interesting and very important topic and in any of your data, ecosystem that you will be having. Now, in very simple terms, when you take data integration and interoperability, it is nothing more with it is more about with respect to the processes that are involved in your data movement, in your data consolidation, right? And it is not only with respect to database. A lot of people feel with data integration is more. It could involve data stores. It could be application involves now, and other types of storage mediums as well. Now, one of the other things which data integration, as the name suggests, it is to integrate, you're trying to consolidate this data into different types of forms, into some kind of consistent forms. This could be, it's primarily, you can use it for communicating, you can try to consolidation and different types of use cases that you might have. Some of your very popular use cases is like your example, you want to do a data migration as an exercise. So data migration, for that you might to migrate the data from one source to your target, and all the types of data migration, whether it's a database migration, whether it's a application migration, whether it's a storage data store migration, any kind of a business process migration. So all of it, you'll see the data movement and data migration is involved. Then similarly, you might have heard about, we have discussed already about data warehouses and data central data repositories, where now we want to bring the data, consolidate the data into the central repository, like for example, data lakes, data lake houses, and on top of it, we want to have the data marts, right? So in that process or in that use case also, you will see that data more involved, data integration. Then you might also see use cases where you want to integrate some of your vendors' data, third parties' data, so that would be there. Or let's say, for example, you want to share this data with some of your actual users. Let's say, for example, you have different set of users, MIS teams, the reporting teams, and your external organizations like regulators and all also. So there also you will see that data sharing plays a very important role. Then you will also see that in your organization, the business continuity teams, right? So they might want to archive the data and keep the data. We don't want to keep all the data in my live systems because again, from there are performance benefits and all the data is not relevant that I want to keep in my transactional processing system. So I keep on archiving data. That is also one of the use case where you see that data integration would play a very important role. Then you might also want to, and as part of this data integration, you'll see that it would be catering to both your structured data, unstructured data, and all your decision support systems, right? Now, if you see, there are two key terms as part of this, right? Which is your data integration and data interoperability, right? Now, integration, as we were discussing, is more about we are trying to integrate the data. We are trying to move the data. We are trying to consolidate the data, right? And interoperability. Now, a lot of times you will see that while we try to integrate the data, the source and the target might be very different. Let's say happens like, for example, if you want to do a database migration, like from example, Oracle to Snowflake or something, so they will have different syntaxes. Now, a lot of times when you migrate this data, when you move this data, it might be moved but it not be able to be used because the formats might be different, the syntaxes might be different, and at the same time within that entire target, also it might also have to start interacting, right? So, for example, a data warehouse. Now, when you are trying to bring in the data from multiple disparate sources, now finally, once you have all this data, they should start speaking to each other. They should be able to communicate with each other. So, interoperability is the process or it's the term where you're trying to bring all of this together and try to ensure that all of the data is able to work, with the other data which is been brought in. So here you will see these data DII solutions which will be happening, right? So these are some of these use cases that I was mentioning, we'll have a lot of these things. Now, data integration and interoperability is dependent on some of the other areas of data management. Like, for example, you have data governance teams because data governance will try to govern the transformation rules, the messaging structures that are important. It is also dependent on the data architectures, right? So when you want to use it for designing the solutions, it is also dependent on the data security aspects, so solutions which will require, you to start protecting, right? So the security of the data. This security of the data would be again for your on-premise, for your cloud stores, all of it, and metadata. Metadata will be also important because a lot of time when you want to move the data, what is this data about? What are the business rules? What is the transformations requires, business values? So all these kind of things is something which metadata comes in. Then on the data storage and operations perspective, let's say, for example, when you want to manage the physical instantiations, need to know what is the source, what is the target, what is the formats, what are the syntaxes. So data storage and data integration and interoperability is important. Then for during your data modeling piece, right, when you have created your physical model, now that physical model is not usable unless you start moving the data. So you will require to have a data integration solution or data integration rules or practices, which will enable you to start bringing in the data, right? So that is all. You will see that some of these are important things. And this also takes us as an extension to the different types of business drivers, right? So one of the most critical driver for DII is more with respect to that you need to move data. And this movement of data has to be efficiently done. Because as you see, as I was mentioning, there would be hundreds and thousands of databases, data stores, tables, columns that would be there between your source that you want to move, right? So how it becomes very much critical. It becomes a very central responsibility that how you're able to manage this entire processes. So all the resources, the capabilities, all of it is something how you're able to manage. Now, with new solutions coming in, with new innovations coming in, different types of data stores, different types of solutions, you see that the whole aspect, the data integration interoperability piece is also trying to get improvised over the years, right? So you will see that this primarily this entire space, the entire methods, the techniques are also evolving as because you have seen that different techniques are coming in and all. Now, coming to some of these essential components, or before coming to this, some of these essential components, what is something I'll just try to show you is what are some of the goals, what are some of the entire, the context diagram is pretty much important to understand. So in the context diagram perspective, we have seen for each of these other topics previously, what are the four key goals of data integration and interoperability? So one is that the data that you are having from your source, you're able to provide to your target. You're able to provide it in a more secure manner. At the same time, when you're trying to provide this data into your target, it should be basically be fit for purpose. It should be able to, ensure that there is a regulatory compliance, in a specific format in the what you require, as well as the time frame. So all the quality attributes also, quality dimensions should also be looked into. Now we have a separate topic on data quality. There will be going through each of these dimensions in detail, but just as a high level, I wanted to give. Then, how do you basically try to lower the cost and complexity of managing these solutions? What are the different types of shared models and services that you want to use? Then at the same time, what are the a lot of these movements you have to automate, right? So what are the triggers that will basically ensure that the data movement is happening? Like for example, can I apply a CDC or change data capture to ensure that, whatever the changes and is happening in my source, I try to push this data or capture this data real time in the near real time into my target. So that basically improves the entire, data movement and data usage. So other than traditionally where I used to have the data movement after 1 day, after 2 days, and the purpose for which the data is required for my analytics or for my decision making is used to be getting, I had to wait for that duration, which might not be very much suitable in the current scenario, in the current context of things, because now we want real-time data. So one of the other important aspect is what kind of triggers, alerts, and rules-based engines that we can start building, where I can want to start moving the data. And then the fourth and the most important goal for this entire exercise that we are doing is that the end use cases that we are basically is driving these entire use of data integration is primarily achieved, right? So with respect to business intelligence, analytics use cases, a lot of these use cases are something that are being achieved. So these are some of the four, the main goals you can say with respect to, what are. So one is primarily I want to try to make the data available in the format. I will try to have a data physically and consolidate this data into the different types of subject areas that we are defining. I will want to try to lower the cost and complexity of managing this data. And at the same time, I want to start identifying meaningful events, triggers, actions, part of it. And lastly, that it should be able to support the objectives that I'm trying to form. Now, the next set of topics that I'm going to discuss is primarily the different types of techniques that we can use, right? So one of the very more popular technique that you have is the extraction, transform, and load, the ETL technique. Now, this has been existing since the time the data movement as a use case has started, where we divide this entire process into three main steps, which is extraction, next is transformation, and the final is the loading. Now, extraction could be as simple as, is like extracting, like it could be like in the form of select statements, where you are trying to extract a specific set of data. Let's say, for example, I want to extract the data which has been um, I generated yesterday, or the data which has got modified yesterday. So I will have some select statements written, which I can help me in getting the data from my source database. So that's the extraction process. Now, extraction will come with a specific define, right? So you can do an extraction which is open and completely full. You want to extract everything. And you can have some specific extraction. So that is all will go into your queries, the fine tuning, the clauses that you will have that will help you. What is something that you require? Now, transformation is important because what happens is when the data that you have extracted, it might not be in the same format and you want to load into your target, right? So for example, I have my names of the customers in small and capital letters, both mix of it, but now I want to convert all them into capital characters. Then I will also want to, let's say, I want to sort the data before it gets loaded. I want to basically apply some calculations. Like for example, I get the date of birth of the customers, but I want to find the age of the persons, each persons. So like this, you will have different types of transformations, right? So you have active transformations, you have passive transformations. Some of these transformations might change the output, the input that is going in and the output that is coming out might change, So like, for example, you have filter transformations, right? Like you want to filter out certain records which has been extracted, if these criteria are not met. So those will be then, let's say 10 records are being input as there as an input, but output you'll see only 5 records. So the number of records which are going as an output is changing. So these kind of transformations you'll see are one set of transformations, and on the other set of transformations where the source and targets will remain same, only the data is getting changed. Like I mentioned you about the cast transformations, where we are changing the alphabets from lower cases up to upper cases. So if you see these transformations, different types of transformations are there. You can group, you can aggregate, so these kind of transformations are also existing. Some of these transformations can go and change the format. Some might change the structures. Some of these might change the semantics also. Like for example, as I was mentioning, I want to represent the gender codes, which is 0, 1, 2, 3 into some specific values like unknown, female, male, and these kind of things. So I'm trying to convert or have some lookups. Or let's say I want to dedupe the records. I don't want to load all the duplicates data, or I want to change the order. I want to sort the data. I want to, order the data. These kind of things also, different types of transformations, and you'll see a lot of solutions out there which has a lot of different set of transformations. Like you have transformations like date parser transformations, you have transformations like sequence generator transformations, lookup transformations, you have parsing transformations, right? So different types of regex expression transformations, different types of transformations exist. So transformation is the stage where you're actually modifying the, the or transforming the data, which might be useful for achieving the target or when you're trying before loading the data. And then you have the loading step where you can be it could be inserting the records, you would be updating the records, you will be upserting the records, you might be modifying the data, right? So this is primarily the ETL process where it is involved of these three steps, which is extraction, transform, and load. In fact, if you remove a lot of times, you don't might not be wanting to do any kind of transformation. So you might want to do an extraction and load also. So the basic form of data movement is the extraction and load. An example of extraction is load as primarily, let's say you have the data in your staging area. So staging area is where you want to just take the data from your production and want to just load it. You don't want to apply the transformations, any transformations. But once this data is loaded into your staging area, then you can want to start using this data and apply the transformations. So the from your source to your staging, what you're doing is just trying to do a extraction and load. You're not applying any transformations. And but when you want to now move the data from your staging to your data warehouse final model, then you want to do an extraction transform and load. Okay. Now, what happens with an extraction transform and load is, if you see the transformation step is sometimes it might be because it would be processing on this entire data. It takes a lot of time to apply these transformations, right? So a lot of times when the data is coming, continuously coming, there is, you want to have the data. You don't want to apply the transformations on the entire data sets because all of this data might not be required. At the same time, the data is continuously coming. So if you start applying the transformation, you might end up losing the data, right? So for you, you might start thinking that for me, it is important that I first start loading. And now once the data is being loaded, then parallelly I can apply the transformations or I can apply selective transformations when I'm trying to load this data, right? So this is more started getting a lot of popularity when big data type of data started coming in. Now I want to start processing data in more real time, more agile kind of use cases started coming up. And that is where your ELT kind of setup started becoming more popular. So what I'm doing is I'm just extracting the data. I'm trying to load it into my these clusters, like or the buckets that we might have. And while the data is getting stored in the form of files, like for example, the stock market movements, or let's say, for example, the data streams types of data that is coming in. I want to, like, for example, the Twitter's tweets that is coming in, I want to start loading it and then I can start reading it because, multiple files will be getting generated, right? So while one of the file gets completed and the other file is getting generated, I can start processing, I can start transforming this data and start moving it into my more structured sources or I want to start using. So that is where you can see the ELT is a newer type of data movement integrations, which is getting a lot of popularity. Now, primarily, if you see some of the other components or some of the other things, as you can see, which is I'll just cover is one is mapping. Now, one of the very important exercise that normally you do as part of your, data integration is your data mapping. So a source to target mapping is what you normally do because what happens is you need to know the target. So when have the target and you want to start mapping from which of the source that you want to start loading, what kind of rules or what are the business rules that I will use for getting the data, what are the kind of modifications that I might want to do when I want to ingest the data into my target. So that is your source to target mapping exercise. It's a very comprehensive exercise. It's a kind of a precursor even before your data. You can start creating your rules and all, right? So normally you have discussions with your business technical teams. You bring them together, try to complete this source to target mapping. Now, the second component is the latency. So latency is the time difference between when the data is getting generated in the source system and when the data is being available for use. Yeah. So like this is where, as you can see in ETL kind of in batch driven kind of use cases, the latency will be very high, because I might be processing the data after 1 day, after 2 days. So the data has been generated in the source, but the user is getting who is preparing reports and all after 1 or 2 days. So latency would be very high. But if you take event-driven kind of architectures or synchronous kind of real-time kind of applications, then the latency I want to remove the latency. In fact, if you see the latency for streaming kind of architectures is as low as in microseconds and milliseconds. Like for example, if you take this autonomous self-driving car, right? So the car, when it sees that there is an animal crossing the highway, it will have to apply the brakes, which has to be happening, in less than a second, in microseconds. If it says that, let this data get generated tomorrow after few days, I will apply the brake. And then, where the animal would be going and where the car would be going, no one knows, right? So the latency has to be going down in very microseconds. Then if you see even the batch related data, right? So as you have seen is batch is where, you're trying to take an entire batch of data. I will say that, okay, I cannot keep on, loading and processing the data every time because the data might not be changing, that is very faster. Then what I do is I do want to do an entire batch of data. So what happens is in a batch of data, I wait for a specific instance. Let's say at the end of the day, I try to take all this data that is there. And what I do is I basically try to take this delta, so this delta I try to do, and then I take this data from a point in time, which is also the snapshots that I would be using, right? Now, batch related data has been existing, since earlier days. It still is there. Normally, this kind of data I will use when, I can wait for the data to be loaded next day for processing. The reporting that I want to do is it could be next day, right? Real-time use cases are not going to use batch related data, but mostly in those kind of scenarios where, I can still wait till the end of the day and next day I can get the data before the next day, start of the next day, I can get this data. Then you can see the batch data is a use case. Now, change data capture is a very popular method where what I'm trying to do is I will try to increase the data ingestion, to change, I will try to improve on the batch related movements. What I will do is I will try to filter on this data that has primarily changed over a specific time frame. Let's say now I want to make it in a more real time kind of a use case, near real time. Then what I do is rather than waiting for the entire day, I will wait for every 15 minutes, So in this 15 minutes, what I will do is I will see whatever the changes that is happening, like any new data that has been inserted, any modifications that has happened to existing data, any deletes that has happened. So let's say at the end of the day, I might have to process 10,000 records, but every 15 minutes, if I see, I might only have to process 1,000 records. So processing 1,000 records will be much faster as compared to processing 10,000 records at the end of the day, right? So that is what the whole objective is. I am not doing as a real time kind of a use case, but in near real time, let's say 5 minutes, 7 minutes, 8 minutes, whatever the time frame that I define, I can. Now, within the the change data capture, there are three techniques that I will use. So in the first technique, what I will do is the source system will try to populate some of the specific elements. Like I will have a timestamp, so this timestamp will have what there would be a code that will try to, an indicator that will say that this data has modified, so you can use some of the SCDs also, like you have the last modified date or, flag to say that, the data has been modified. So you can use that. Now, second thing Second method is where I can add some level of identifiers when the metadata is changing. So this will be helping me to select, like for example, last updated date or last updated time, this kind of thing. So when the time frame is coming in, I know that from this time to this time, this data will get selected. Then the third method that I can have is where the source data that I have has changed into a separate object itself, which I can start using as part of my extraction process. So these are something that is very few use cases, where the data is getting completely changed. So I will try to see the previous value or the new value and then try to identify based on the history reports. So these kind of things I will try to use for creating the change data capture, right? This is very much useful in log based. I will might start using my logs to try to see what has been changed in last 10 minutes, and then start using this. So near real time versus event driven, if you see, so near real time was a use case that I just mentioned, right? Now, event driven is where, there is some kind of an event that has happened, and because of that, the modifications or changes has happened. Like, for example, this is more your with respect to your any kind of a decision systems or, an update kind of systems or applications that is processing at a specific interval every changes that is happening. So any kind of an event that has got triggered, that might basically led to the modification of the data. So let's say, for example, there is a power outage. So there is an event that happened, and based on that, what all changes that has happened. Or let's say, for example, there is a file that has been received. So that's a kind of an event that has happened. So event is any kind of an incident or any kind of an action that has happened, which from different scenarios could be different. That is basically triggered the kind of processing and movement of the data. Now, this type of data, or the data movements, you can have it in a asynchronous kind of fashion or a real-time synchronous kind of fashion. Now, in asynchronous kind of a data flow, what happens is the source system that is providing this data will not wait for my receiving system to acknowledge the data. So it will keep on continuously changing. So the source and the target, which is there, in case if they are in sync, so they are in sync as in, like, for example, there is no time delay or differences between my source and target. So in these kind of situation, these are also called as synchronous, right? The data in one of the data set has to be kept perfectly in sync with my in the other. Like, for example, your production and your DR systems, right? So in your production, whatever the changes is happening, it has to go into my target. So I will not wait for my DR to acknowledge. It is provide me a confirmation that yes, you should mention. I should say that these are been synced up. Everything has been done. Then, as compared to that, in asynchronous, what happens is the system will have to wait. The target will say that, yes, now you can start sending me. I am ready to accept. So this kind of data integration is asynchronous based data integration. What it does is it might not be preventing my source application from continuing to process. So at any point in time, these asynchronous kind of things might be causing some kind of a delays, so because they are not in sync, the target is primarily not having a kind of the data updates that are being made to these targets is more in an asynchronous kind of configurations. They are not very much immediately happening. So it might be some kind of a delays which might be there. And then, as I was mentioning, low latency and streaming, I explained it so I'm just skipping. So this primarily is the lowest kind of things. You can have your IoT use cases, social media, your credit card transaction processing, fraud detection systems. All these are very examples. Your OTT platforms, streaming platforms, all they are using your streaming kind of data. They has to have the lowest latency, right? If you now are watching the IPL matches or the FIFA World Cups and all, then you know that, I cannot have I am using a streaming telecast of the entire match. So you see the latency has to be very low. That is primarily. And replication is where I want to start replicating the data. So replication in the very simple terms is where you're trying to have copies of your data sets, So replication solution or replicating is where, the data is getting replicated across your other sources. Now, replication is important is for your big data kind of sources, like for between your master nodes and your worker nodes, you see that I have these different topics and partitions where I'm trying to replicate. So replicate basically, replication improves the data capture and the data residency of, because at any point in time, if I want to apply parallel processing and those kind of aspects, then that is something that would be very much possible to do. Then we also have archiving, where I want to archive this data and keep it into an alternate data structure. So, this data, like for example, you have a bank account and, since the last 50 years, right? So let's say now all this 50 years data, you cannot keep it into live system. So you might keep the last 5 years data, but all your other old data might be there archived into an archival environment, archival data store. So tomorrow, if you want to request all of this data, passbooks and all, you can place a request and the data could be taken out from the archive. Yeah, but for the performance in the transactional processing systems, keeping it might not be a very useful use case. Then the enterprise message format or the canonical model, if you see. So canonical model in very simple terms is a more of a common model that will be used by the entire data framework, where what you're doing is we are trying to use a specific exchange medium, specific format that you might be using, right? Now, so this is part of a design pattern, like what is the kind of an interaction that would be happening between the systems with the other systems, and at an enterprise level, what is the kind of an enterprise format that you might use. So a lot of times we use the enterprise service bus, as to establish and achieve the model. So it might tell you, that rather than different systems having different types of, messaging formats and messaging mediums, we define a kind of a messaging bus, enterprise message service bus as part of my middleware that can regulate the way the data is, okay, the message formats that are being used consistently. Then you also have the interaction models that basically will help you to make the connections between the systems, whenever you want to transfer the data. Now, these interactions model could be also of different types. Like, for example, you have a point to point between point A and one point A and point B. The data interactions is happening directly. Now these, or it could be hub and spoke kind of a model, which is more an alternative to point to point, where we are trying to consolidate this data from the multiple sources into a central data hub, like a data warehouse and all, right? So data warehouses and data marts are very good examples of this. And normally these enterprise service buses are the integration solutions that I might be using for, because it has to bring in the data from these multiple sources into single place, right? Then you also have the publisher subscriber kind of messaging data. So this is more useful for your streaming kind of systems data, where now you're using a very popular architecture that uses this PubSub kind of an architecture is like your Apache Kafka. So you have the publisher, which is primarily will going to produce or push out the data. And then you have the subscriber, which is trying, the other systems that will try to pull in the data, right? So publisher pops up kind of an architecture. You will see any of your architecture or messaging, messaging queues and all you will use. So they will have this pop sub kind of an architecture. Now, coming to some of the architectural concepts that is part of these entire, these aspects is one is your application coupling. So application coupling, which defines, what kind of an architecture will you have, whether it's a market microservice-based architecture versus your monolithic-based architecture. So how the different layers, your application layer, your front-end layer, processing layer, your data access layer are coupled. So if it is very much tightly coupled, so they will have a synchronous interface, as in like a monolithic kind of an architecture. So one system will wait for the other, because of this tight coupling. Now this might be a little riskier because of your modern kind of architectures, which is more of microservice-based architecture. So you're trying to lose the coupling in this kind of architectures. So you might not wait for each of the systems to provide a kind of a response. Each of them, they have their respective services. They would be working, and you have the APIs connectivities between them that can. So Red Hat OpenShift, if you take in, is a very popular kind of Microsoft service kind of an architecture that you will have, right? So this is a more of a service-oriented architecture if you take using the enterprise service bus. This is also an example of an loosely coupled architecture. On the other side, you have the orchestration and the process controls. Now, orchestration, as the name suggests, when you want to execute multiple processes, you want to organize them and you want to execute them, right? So that is very much important. So you want to define how what are the different steps that are involved and then handle these messages or packets. So that is your orchestration, so transformations, your orchestration is a very important component for any of your integration solutions. And while you're doing that, what kind of process controls are important? That will ensure your safe shipment, delivery, extraction, and loading of your data. So that is also important. And a lot of these data movement architectures, you will see that it will have your database activity logs, your batch logs, your alerts logs, your exception logs. All these different types of components you'll start seeing as part of it. Along with this, you have the enterprise service bus, as I was mentioning. The service bus is like a system that will act between, it's a middleware. It will act as an intermediary between your systems. It will start passing these messages between these different systems. And is all the messaging that is happening, the sending and the receiving the messages or the files will be happening through the enterprise service bus. Now, they might be encapsulated from the other processes, right? So, for example, the enterprise service bus acts as the service between the different applications. Right. So these kind of different types of components that you have. Then we also have the service-oriented architecture, as was mentioning, that where you have rather than a single service, we have a service, a gamut of services that would be there, multiple services that would be interacting with each other, right? So a lot of times what happens, the applications might not have the direct knowledge of interacting with the other applications. So service-oriented applications will basically ensure that the interactions between the different systems is happening. So that is your service-oriented architecture. So this each of these data could be self-contained into their respective containers you can have. So a lot of times Kubernetes and Dockers are very useful for driving a service-oriented architecture, and the data respectively could be interacting with the others using our RESTful APIs using the services that can help them in pulling and pulling the data, pushing the data. All of these are something that you can have. And then you also have the complex event processing kind of use cases where the events data needs to be processed also. So wherever the entire tracking and analyzing of the streams of data needs to happen, you'll see the complex event processing kind of an architecture comes in. So since these data are being captured in the form of events, so events are like your opportunities or threads. That would be what is the kind of an activity that's coming in. So normally any kind or the organizations will try to use these events. They will try to predict the behavior or the activity. They will try to identify the responses that is coming in, the activities that is coming in, and the events that is happening. So based on that, is complex events handling would be possible. Now, coming to some of the integration activities, what are some of these activities? Now, it is primarily defined into 4 different phases. You have the definition phase where you define the data integration and lifecycle requirements. You primarily then perform the data discovery, as part of the planning and analysis. There are different components that you do. So you define the data integration and lifecycle requirements. That is primarily what is the target, what is your requirements that is there as part of your requirements. Now, this is also you try to take into consideration and have these discussions with your organization, align with your organization policy, speak with your data integration teams who are already doing a lot of these things. A lot of times you will have to take use of your metadata as well, right? So that is very much, these are a few things that you will try to take into consideration. Then you perform data discovery. So data discovery is done by you do data profiling, So data discovery is to identify all the potential sources of data. What is the integration efforts that would be required? You might want to do the data discovery to know where exactly which data is residing, right? So sometimes these metadata management solutions are very useful because they will be having a complete idea. So that is where data discovery is being facilitated or been driven or been assisted by these metadata management solutions. So while you're doing the discovery, you also try to assess the quality of the data. You also see whether the data is fit for purpose. You try to look into some of the documentations. You try to do some of the data profiling as well. And this primarily the data discovery will give you a complete understanding of the underlying data. The second thing that you do is the next thing that you do is which is you have to document the data discovery or data lineage. Now, sometimes when you don't have an automated data lineage solutions, then you might also want to document a lot of these things. So documentation will give you a high level understanding about how the data is being collected, how the data is being acquired, is being transformed, has been processed, stored. So the entire journey, the traceability of the data becomes very much important, will be very easy. And then you also try to document the different rules, business rules, the transformation rules that are being used for moving the data. Sometimes you have to go through all your ETL codes, the procedures, functions while you're doing this entire analysis. Itself is a very exhaustive exercise. Then profile the data. Profiling the data is primarily where you try to understand what is the data content, the structure, what are the, some of the differences that might be there. So profiling is a very simple term. In very simple way, if you want to understand, it gives a understanding of your like if you have done exploratory data analysis, or if you have seen, the statistic, the minimum value, maximum value, the count of them, then what is the kind of a pattern of data that it will be having. And it can give you understanding a histogram analysis, a correlation analysis, all this of some of the things that it can give you. So data profiling, if you see, it can give you the formats of the data. It can give you the underlying of understanding of the underlying values, that the null values, blank values, default values, set of values, list of values. All of it could be provided. The list of valid values. What are the kind of patterns, relationships? All of it is being provided as part of profiling. So the profiling whole goal is to if you have millions and millions of data, I cannot go through each of the data set to understand. So it gives a consolidated view of understanding how the underlying data. It's more like, so if someone asks you like your profile, so you cannot just say that you cannot take 17 years to or 20 years to, explain about your profile. What you do is you have a one pager that basically summarizes all your 17 years of 20 years of experience, right? So that is what with data also. I cannot look into all those millions of records, but I want to get a one-page view of the understanding the underlying data. So once I do the planning, the second thing is to start designing, right? So the designing aspect where we start doing is I start designing the data integration solutions. So as part of the data, right? So what I do is I try to design the solution in such a way that it will start to meet the final objectives or the requirements as part of my DII. So I will establish the enterprise standards. I will try to implement these individuals, right, based on whatever the planning analysis that I have done. So now I'm trying to design, what are the kind of requirements that I might have. I will try to create an inventory of the different types of data structures that are involved. I might try to get in an orchestration frequency of data flows, regulatory components which are required. All of it is something that I'll try to do. I will try to select an interaction model, right? So like an hub and spoke model or a point to point or a PubSub kind of a model, which is the one that is more suitable. I will try to design the data services, exchange patterns which I might be having, right? Like for example, the X services, which are the data services that would be involved as part of it, kind of exchange patterns that would be required, right, for moving the data. So these kind of things I will try to design as part of it. I might try to design some of my model data hubs and interfaces, right? So as part of the next step, I will try to identify NDM kind of data hubs. I want to create data warehouses, data marts, operational data stores, all of it which is required. I will try to involve. And what is the kind of an data movement strategy, whether I might, what is the message layout that I might use? What is the kind of a model that we want to use that I'm going to use? Then I will try to map the data sources to my targets, right? So the data source to target is where I will try to this mapping exercise, which I was mentioning, right? So that is all part of a design stage. So in this source to target mapping, it's a very comprehensive, it's a very time consuming exercise. You will have to go and start mapping each of your target data fields one by one. And it also depends what is the scope of your target, right? If it is only one entity, two entity, or if there are hundreds of entities. So it's a very comprehensive, it's a very detailed exercise, you know. Next is you also try to define or design the data orchestration components, right? So what kind of data patterns that or data flows that you might have to do. Again, this you might document it during your analysis and planning analysis phase, but the designing part of it will start designing as part of your design stage. And then you can have batch type of data integration orchestration, you know, so you define what is the frequency, what is the data movement, how it happens. You can have schedulers, you can have triggers defined at a certain point in time, periodicity aspect. You can have real-time data integration orchestration. So real-time data integration orchestration might be triggered by some kind of an event. So what is that event? You know, you have to define that events. Now, once you design all of it is completed, then you start developing, right? So as part of the development, you start developing the data services. What kind of services that might be required to access, transform, and deliver the data? What kind of tools that you might have to use. You can have multiple solutions like the MDM solutions, DQ solutions, and all in addition to these, right? So what are those components that is required? Then you start developing the data flows, right? So in the data flows development, what you try to do is you start developing whatever the flows that has been created. So this is where, you know, the entire all the detail jobs and you know these kind of things you might be and it you might use a solution definitely because creating those might be very easy or sometimes you also try to create them in the form of procedures and you know as I was mentioning ETL could be also designed using C select statements and all. So you try to create your functions and procedures also so that can be created. So that is all your data flows that you do where you want to. And then real time, if you want to do real time data integration flows, you will have to define those events. You have to mention how you would be acquiring the data, transforming, publishing, what are the services that are involved. Then you define your data migration approach, you know. So you define what is the kind of an migration approach that you're going to use. Sometimes you might use your migration assistance. Like there are a lot of data migration assistants like data migration, DMA, transfer appliance. You have the S3 transfer acceleration components, right? So each of these sources, if you take each of your cloud sources or any kind of a migration assistance, so these are very useful as part of your migration exercises because they define what is the scope, how you want to create. Then what is kind of a publication approach that you want to have? The publication approach will try to define some common messaging definitions with respect to the data, you know, and ultimately it will help your data consumers, the people, the users to have the appropriate right of access authority with respect to these data sets. And you know, once this data, the new data, how it needs to handle the change data, how it needs to be pushed, all of it is something that has been defined as part of the publication approach. Then you have the developing the complex event processing flows. So in here, you will try to develop the different types of event processing solutions. How will be prepared the data, historical data, how will be, you know, process the real-time data stream, how will try to execute the triggered actions, you know, with respect to the predictions and the events that is happening. So this is primarily the event processing flow, the preparation and pre-processing of the historical data that you might have, where the data is being processed at night, batches, or in near real time. That is primarily defined as part of it. Right? And what is the kind of a response that you might be getting with respect to the identification of a specific event? You know, that will be saying, let's say, warning and error that has happened. Those are specific events also that could also be some trigger points that you can have. Then maintaining the metadata. So throughout this entire exercise, having your metadata maintained and captured is something that is important because ultimately this might be reused in the future for any further use cases as well. So documenting the data structures, documenting the definitions, technical business definitions, the transformation logics, all of it is something as part of your metadata to maintain for the DI also. You try to maintain the DI, the you take a sign off. then what happens is so after you take a sign off primarily, you might be getting some kind of a use case where what happens is you might have to take sign off, you might have to implement it, and once you have implemented it, you want to start monitoring, right? So monitoring would be in the form of dashboards, in the form of use cases, or there's an operation teams that can come in as well. There are different types of tools and technologies it could be used as part of it. So you can have a data transformation engine or an ETL, ELT solutions. A lot of solutions are out there: Informatica Power Center, IBM Data Stage, and now ISAS, which is your cloud services from Informatica. You have SnapLogic, you have Matillion ETL, a cloud native solution. You have StreamSets. So many different types of solutions are there that could be useful. You have Ab Initio, you have some of the other solutions which out there, so many data services and on the cloud services, Azure Data Factory, AWS Glue, Cloud Data Fusion, Cloud Proc, Data Proc, Cloud Data Flow, so many solutions out there on the ETL, ELT capabilities. You can have a data visualization, data virtualization server. So these data transformation engines normally will be performing extract, transform, and load, right? These data virtualization servers will perform this extract, transform, and integration virtually. So data virtualization servers can combine all your structured and unstructured data as well. Normally, your data warehouses, which is an example of your data virtualization server where you want to virtualize and keep this data. Then enterprise service bus we have seen. So that would be the model that we want to use for managing your message-oriented middleware, right? So I want to have the service bus to implement the near real-time messaging between your data stores, applications, and servers. So most of your internal data integration solutions that might be have available, you want to execute more frequent and daily, a kind of an architecture. So this asynchronous format, which I might be using, is where your enterprise service bus will be coming in. And enterprise service bus can also be used synchronously also. Let's say, for example, these when it wants to implement incoming and outgoing messaging queues. So all of it, I might use a messaging interface, a message interface that could be an adapter or an agent which is installed that manages this data movements, right? So this processor will try to keep the systems that are there subscribe to what kind of messages they are looking for. And ultimately, there is a polling kind of mechanism that you will have where these messages and the incoming messages, outgoing and incoming messages are being managed, right? So this is where you have the enterprise service bus. Then you have the business rules engines where you would be defining all the business rules. So these business rules primarily will be, one of the important thing that we have seen, which is your metadata. You can, as part of that exercise, you have this business rules engine that will allow you, all your users to manage these business rules that would be useful. So documentation of these business rules and the technical rules, translating those business rules into technical codes is what the business rules engines will manage. Data process and modeling tools. So as part of the data modeling, you might require data modeling solutions. That is another thing. Then you have the data profiling tool you can have separately to understand and profile your data, right? You have a metadata repository, a central metadata repository you can have, which captures your data catalog and with glossaries, your data lineage, all of it is something that it can provide, right? Now, different types of techniques you can use, right? So as I was mentioning, different types of techniques that you can have includes your different types of models. You can have your tightly coupled kind of an architecture and techniques. You can have your, primarily also the loosely coupled service-oriented architecture. It also depends on the what kind of an architecture stance you're using. Some of the implementation guidelines is first is you have to do an assessment of it. So here, while doing the assessment, you can use frameworks like data capability assessment, frameworks like a DCAM framework. You can also use some of your assessment, any of the other assessment frameworks that helps you to understand and perform a complete readiness and risk assessment. What kind of an integration, policies that you have, what kind of integration methods that you have, and what kind of it will help you to understand what is your as is state and accordingly take time for going and understand what is the target state that you want to define. You try to see if there are any solutions that could be that has these capabilities and could be leveraged as well. because in an organization you'll see so many different teams are there, right? The different teams might be using different types of solutions. So what different if some solutions are already available as part of some of the other projects and all, can they be extended to a larger extent, right? So that is primarily your center of excellence that creates created, so they basically look into a lot of these your any kind of these strategy initiatives that is happening. And one of the other thing is your organizational culture will change because it is something that all the time, which the methods that might be coming in, right? So local teams, they might be having their own methods, their own techniques, and sometimes they might be are more comfortable with that. Whereas there is certain central teams who have a good understanding of the best practices and tools and technologies. So bringing this change is something very is difficult, So how you can start collaborating, making people collaborate and try to drive some of these initiatives, try to enable them, try to teach them, try to upscale them. That is very much important. And a lot of these programs normally, when you want to transform, it's not very easy because it's about data, right? When you a lot of these programs they fail also because what I've seen is where now you are trying to transform and move it into a data integration solution, for example, the data coming out because the transformations or the logics are not captured correctly, it doesn't come out in the same way how it has to come out, right? So a lot of these times these fails as well. So business plays a very important role because it captured the business logics and all of it is something that is what they try to drive. Now, as part of the governance, the methods, right? So because the data governance team also will be looking into that, they will be taking in a lot of these things. Now, one of the very important aspect, as I was mentioning, the business stakeholders are one of the critical teams who can define the rules. They can tell you how the models and the transformations needs to happen. They should be basically verifying, they should be approving the changes, right? And all of these things should be documented as part of the metadata repositories, the metadata management solutions, right? And this will start creating a lot of transparency, trust with respect to what is happening, right? So as part of your entire life cycle, whether you take an agile-based, sprint-based approach or an SDLC kind of a life cycle, you know these, you start defining these components, these stories, and then ultimately you start having your data sharing agreements in place, MOUs in place, then you start the service level agreements, and then as part of your business continuity plans, disaster recovery plans, how you can see that what are the SLAs, what are the latencies, what are the controls that you put in. All of it is something that you will start doing it as part of it. And lastly, how do you basically gauge the success factor? So there are metrics that you can identify, right? So metrics identifications, KPIs identification is very much important. So some of these KPIs that you can have, it's like for availability perspective, you can have what is the availability of the data that is being requested, what is the time, of availability, what is the volume of data that is being transported, how much is the volume of data that is being analyzed, reconciled, what is the speed of the data, what is the frequency of the data, what is the latencies. Then with respect to the cost associated, how much processes are being utilized, what is the billing, monthly billing that is happening, what is the volume of the data, is all of this data is important or not, how much of this data is junk data, how much of this data is redundant data. So these kind of are the different types of metrics that are being created where organizations start gauging the success factor of this kind of initiative. So I will take a stop here. So this is what I wanted to cover in today's session, which is on data integration and interoperability. So I covered the different types of topics, different types of concepts around this. I also explained you what are the different goals, different principles, what are different integration activities and the stages and the phases of these activities, what are different types of tools that could be utilized, what are different types of implementation guidelines, frameworks as risk assessment and organizational change requirements. And lastly, on the governance side of things, what are the few of the governance controls that might be required as part of this entire exercise. So I'm going to stop recording the session and I'm going to share this on my channel. Please feel free to go and look into it and spend some time to go through it again. and kindly refer these to others as well who are required to have this. And I will come in the next session with another and interesting topic, primarily on document management, content management. So stay tuned. Thank you for everyone for joining today's session. I will meet you in the next session. Thank you.